Hello students, welcome back. I am Alejandro from Victory IB and CAIE Online Academy. During this video we will be discussing parts D and E of the second problem of the 2019 AP Physics 1 exam. Now this problem as well as the entire exam is divided in subparts, so make sure you watch all the previous videos and the following also to have a complete understanding of all the concepts that are involved during the exam. So let's get started.
Part D. Consider the scenario from part AII, where the mass of block A is much less than the mass of block B. Does your equation for the acceleration of the blocks from part C agree with your reasoning? Yes, no? Well, let's find out. Mass of block A is much less than the mass of block B. So, within this equation, mass of block A, what we must understand in part D, is the following. If it happens that the mass of A is much smaller than the mass of B, then the mass of A plus the mass of B will almost be equal, will be very similar to just the mass of B, because the mass of A is not adding much to the mass of B. So, since we have just said that the acceleration was equal to the mass of B times gravity divided mass of A plus mass of B, this will be approximately equal to mass of B times gravity divided by, but now instead of writing mass of A plus mass of B, we're just going to write something which is approximately equal to, which is only the mass of B. Now, in this approximate scenario, we'll end up with an expression in which mass of B can be simplified. So, this is equal to just gravity. And this is what we have just said a few minutes ago, that the acceleration will be close to the acceleration of gravity. Bear in mind that there is an approximately equal to sign in the middle. So we can say that the acceleration is equal to gravity. It will be similar. So, of course, we're going to say that, yes, it matches our reasoning. Briefly explain your reasoning by addressing why, according to your equation, the acceleration becomes or approaches a certain value when ma is much less than mb. This is what we did here as a way of symbolical reasoning, which is okay. Final part. While blocks are accelerating, the tension in the vertical portion of the string is T1. Next, the pulley of negligible mass is replaced with a second pulley whose mass is not negligible. Not negligible. Now we do have a mass. When the blocks are accelerating in this scenario, the tension in the vertical portion of the string is T2. How do the tensions compare each other? Okay. Let's write it down here. We were just told that with no mass on the pulley, no mass, there is a tension. This is block A, this is block B, and this tension is called T1 on both sides, right? There is no mass, the pulley needs no mass to rotate. Sorry, it needs no torque to accelerate, start rotating. Now, we do have mass on the situation that has been described to us. We do have mass. if there is mass placed upon the pulley, then the tension that it's acting upwards on B, it's not the same as the tension acting rightwards on A. This is because, let me zoom in here. This is because this is a pulley, string going in one direction, string going in a different direction. This tension and this tension cannot be equal now. If we have mass on the pulley, we need a higher tension on this side than on this side, because otherwise the pulley will not rotate. It has mass. If it has mass, it has a certain amount of inertia, of rotational inertia, and we need a higher amount of tension on this side acting downwards than on this side. The problem states that this is called T2. Now, a key element that we must identify to be able to explain, to describe what's happening in here is the following. The acceleration in a situation in which the pulley has mass will be smaller than the acceleration in the situation in which the pulley had no mass. The new acceleration is smaller. Why? And that the y, it's related to the fact that as B is moving downwards, it's not only pushing A to the right, but it's also pushing and trying to make that pulley rotate. So the system will now need not only to move A, but also to start rotating the pulley. The entire system is moving with a smaller acceleration. Therefore, out of the two forces that were acting on B, its own weight, mass B times gravity, and this tension that it's now called T2, since B will be accelerating with a smaller acceleration, now T2 must be close, must get closer to the weight of B. So what we must state is that this is our answer. Let's write it with a different color. None of the things that I just draw with blue color is required. Our statement is that T2 will be bigger than T1, that the original tension. Why? We'll say something like this. The system will move with a smaller acceleration, with a smaller acceleration, which implies that T2 is bigger than T1. That's it. End of the problem.
Okay, thanks for watching. Please do watch my next video for the remaining part of the exam. And also don't forget to register on our website www.victoryonlineacademy.com for a free demo registration. I'll see you all on the next video.